Hi everybody. Today we're going to be doing a homework review of the trigonometry assignment. I meant to do it yesterday. I apologize. Was not able to, but better late than never, I guess. So we're going to start and just do all the odds. Okay, so the first group of problems asks us to identify the trigonometric ratio, and I'll remind you that we're going to use our SOHCAHTOA, our acronym, to help ourselves remember. So sine of z. Z is going to be our theta. This is going to be our hypotenuse, this is going to be our adjacent, and this is going to be our opposite. Okay, so sine of theta is going to be, remember, OH, so SOH, so opposite over hypotenuse, because SOH, right, opposite hypotenuse. And our opposite is 28, and our hypotenuse is 35. Those are both divisible by 7, so we're going to get 4/5. That's it. Okay, next one, tangent. So of A, so theta is here. So this is opposite, this is adjacent, and this is our hypotenuse. Okay, so tangent is going to be opposite over adjacent. So opposite's 24. So tangent of theta is, I'll write it again, opposite over adjacent. So tangent of A is going to be opposite 24 over adjacent 32, and those are both divisible by 8, so we're going to get 3/4. Okay, tangent of A again here, so this is our theta. Tangent of theta is opposite over adjacent, and this is going to be our opposite. This is our hypotenuse right here, and this is our adjacent. We know it's hypotenuse because it's opposite the 90-degree angle. So opposite over adjacent, so we're going to say tangent of A is going to be 32 over 24. Okay, and that's going to be, let's see, they're both divisible by 8 again, so that's going to be 4/3. Okay, and number 7, sine of x, so x is our theta. So this is hypotenuse, this is opposite, and this is adjacent. So sine of x, sine of theta is opposite over hypotenuse. So sine of theta is opposite over hypotenuse. And sine of x is going to be, this is the opposite's 20, and the hypotenuse is 29. And we cannot simplify that, so it's just 20 over 29. Okay. And the last one from that group is going to be number 9. So A is where our theta is. It's hypotenuse, opposite, and adjacent. So sine of theta is going to be opposite over hypotenuse. Sine of A is going to be 35 over 37, and that cannot be simplified either. So there you go. All right, so those are the first set. So it's basically you have to establish where theta is, right? And once you know where theta is, you can assign adjacent, opposite, and hypotenuse, and then just basically use the appropriate ratio. Okay, so this one now. Find the missing side, round to the nearest tenth. Okay, so I'll write SOHCAHTOA again, just so it's on the same page. Okay, so this is our theta. So if that's our theta, this is our hypotenuse, and that's going to be our opposite. So which is opposite over hypotenuse? It's going to be sine. So sine of theta equals opposite over hypotenuse. So sine of 69 degrees equals x over 14. Sorry, x over 14. So now we have our ratio, but we have to find this value, which is the missing side. So I'm going to look in my trig table to see what sine of 69 degrees is. So here's our trig table. Here's 69, and sine is this first column. So it's going to be 0.9336, or 9,336 10,000ths for all you place value snobs out there. So yeah, we're going to put that in there. So, okay, so 0.9336 equals x over 14. Okay, and now we just solve this algebraically. So we're going to multiply both sides by 14, and that'll give us the value of x. So x will equal, let me separate this, and I'm going to use a calculator because I definitely do not feel like, I'm going to be a little lazy here. So I'm using a calculator off screen. I apologize, I don't have a calculator ready. I should have one. and we're going to say 14 times 0.9336. So that's going to be, it says round to the nearest tenth. Okay, so I have 13.0704. So nearest tenth would be this place value here. So 7, because it's 5 or higher, this is going to become 1, so it's going to be 13 1/10. So this is it rounded. It's an estimation, right? So there you go. Okay, let's do the next one. So here's our theta. So this is our theta, this is our adjacent, and this is our opposite. So opposite over adjacent, that's TOA, so we're going to use tangent here. So tangent of theta equals opposite over adjacent, and tangent of 64 degrees equals 20 over x. So let's find tangent of 64 degrees. So 64 is here. Tangent is the third column, so it's going to be this one, 2.0503. Okay. So we're going to use this value here. So 2.0503 equals 20 over x. We're going to multiply both sides by x to get it out of the denominator. And we're going to have 2.0503x equals 20. And then we're going to divide both sides by that weird coefficient we have. 2.0503. It's going to be a little under 10, I believe. I'm going to do this off screen on the calculator because, again, I don't really feel like doing that by hand. So you'll have to forgive me. 20 divided by 2.0503. Yep, just under 10. So we have x equals 9.754, and it goes on forever. So this is going to be rounded to 9.8 because this is 5 or higher, or 9 8/10. And there you go. Let's look at the next one. So we have our theta is here, which means this is our opposite and this is our adjacent. So it's another tangent. So tangent of theta equals opposite over adjacent. Okay, so tangent of 72 degrees equals x over 11. So again, I'm going to look at my column here. So 72 degrees is here. Our tangent is our third column. You can see up here a tangent. So 72 degrees here, tangent, so 3.0777. Okay, so we're going to write 3.0777 equals x over 11. And we're simply going to multiply both sides by 11, and that'll give us our solution. So x equals, and 3.0777 times 11. So we get 33.854. Okay, but remember we're rounding, so this will become a 9 because it's 5 or higher, so 33.9. And there we go. Okay, number 17 here. So our theta is here. This is opposite because it's opposite the angle, and this is our hypotenuse. So opposite and hypotenuse, that's going to be our sine functions. So sine of theta equals opposite over hypotenuse. So sine of 27 degrees equals 10 over x. Let's look in our trig table. So 20, was it 27? Yeah, 27. So 27 degrees is here. Sine's the first column, so this is the value we use, 0.4540. Okay. 0.4540 equals 10 over x. Multiply both sides by x. So we have 0.4540x equals 10. And then we just divide by our coefficient here. 4540 x equals. Here we go. It's going to be 22.02, so this will be 22. Okay. Again, that's an estimate. Okay. Hopefully that alleviates that. Let's do the last one of that grouping. So we have 19 here. Here's our theta. This is our opposite. And this is our hypotenuse. Okay. So opposite. Oh, let's write our function on here. SOHCAHTOA. Okay, so opposite over hypotenuse is a sine function. So sine of theta equals opposite over hypotenuse. Sine of 57 degrees equals x over 19. And sine of 57, so let's look at 57 degrees. 57 is here. Sine is our first column, so it's going to be this value here, 0.8387. Okay. So 0.8387 equals x over 19, and then we multiply both sides by 19. Okay, 19 times 0.8387. So x equals 15.93, so it's going to be 15.9, or 9/10, I should be saying. Okay, so that's how you find missing sides. All right, so it's a little more involved than the ratios, right? Mainly because we're solving things algebraically with a little more involvement. Okay. All right, the last grouping, find the measure of the angle. So now we're looking for the missing angle. We're going to be solving almost the same way, just the variable is going to be a different spot, which you'll see. And this one involves a little bit of subtraction in order to find which one's closer. Now it's asking us to find the measure of the indicated angle to the nearest degree, and that's going to involve some estimation, which you'll see. Okay, so here's our theta. This is our hypotenuse. And let me separate these because these tend to get kind of messy. Okay. Hopefully we can fit it all in here. All right, so this is our hypotenuse, this is our opposite. So opposite over hypotenuse, that's going to be our sine function. So sine of theta equals 6 over 13. So now what we need to do is turn this into a forward space decimal. So 6 divided by 13, I'm doing this off screen, it's going to give us this. Sine of theta equals 0.4615. There's a 3 here, so I'm going to keep this at 5. Okay. So now what we're going to do is look for the number that this is closest to in the sine column. Because what we're looking for is trying to figure out what angle theta is. So, okay, so our sine column, let's see if I can put both on the screen at the same time. I really can't. It's all right. So 4615. All right, so here's our sine column. 0.4615. So it's going to be in between these two values. So it's either going to be 24 or 25. Because 24 is this, 25 is this. And 4165 is in between these two values. So what we're going to do is a little bit of subtraction here. So okay, so here we go. So for the 24 degrees, that's the 24 degrees, right? The value is 0.4067, which is smaller than this. Oh, I screwed that up. 4615. Yeah, I totally screwed that up. Never mind. It's not 24 degrees. So that happens when you're flipping back and forth. So 0.4615 would actually be in between these two values. I reversed the 1 and the 6. That's why. So 0.4615 is greater than this, but less than that. So it's either going to be 27 or 28. So we'll start with 27. There we go. Okay, so 27 degrees. 27 degrees is 4540, which is smaller than this, so we'll subtract it from it. So we'll say 4615 minus, and again, 4540. We're going to subtract that and see what we get. So 5, borrow 1 from there, it's 5, that's 7. So it's 75 10,000ths. It's a very small difference. So that's how close it is to 27. This is that close to that value here, 4540. So now 28, put it over here so we have more room. 28 degrees, that value is going to be 0.4695. So that one's bigger than this one. So 0.4695, and then subtract our value here, 0.4615. And that's going to be a difference of, look how close this is, 80, so 80 10,000ths. So you can see that it's almost in the middle, right? It's 80 10,000ths away from 28 degrees. It's only 75 10,000ths from 27 degrees. So clearly it's slightly closer than 27 degrees, but it's awfully, awfully close. So it's 27 degrees. Okay, let's try another one. So theta goes here. Here's our opposite. Here's our adjacent. We know opposite adjacent is going to be our tangent function, right? Opposite adjacent. So tangent of theta equals opposite over adjacent. And tangent of theta equals 16 over 17. And let's divide that off screen. So 16 divided by 17 is going to be tangent of theta equals 0.9412. Now, there was a 1 there, but there was a 7 afterwards, so I rounded to 1, 2. Okay, so now we're going to look in the tangent column and see what two values this lies in between. So 0.9412. Okay. So it's towards the bottom here. Tangent is this third column here. So 9412. It's going to be greater than this, but less than that. So it's either going to be 43 degrees or 44 degrees. So 0.9325. Okay. 0.9325. And this is going to be the 43 degree one. And we're going to subtract this from our value that we have, 9412. Alright, so I'm going to do this off screen because again I'm going to be a little lazy. 0.9412 minus 0.9325. So it's 87 10,000. It's another close one. 0.0087. So that's the 43 degrees. Now the 44 degrees is a little larger, so we're going to subtract from that. So 44 degrees, we're going to take, okay, 0.9412 and subtract that from 0.9657. Let's see what we get here. So 5, 4, 2, yeah, this one's significantly further away. So the difference is greater for 44, so 43, since it's closer, it's going to be 43 degrees. But this one's a lot closer than that. This one was in the middle, this is like significantly closer to that. So 43 degrees. Let's try another one. Okay, so theta goes here. We have our hypotenuse. We have our adjacent. Okay. We know adjacent hypotenuse is going to be our cosine function, which is right there. So cosine of theta equals adjacent over hypotenuse. And, okay, so cosine of theta equals 4/5. So cosine of theta is going to be 0.8000. Okay, so we're going to look for the cosine column and see where that is. So cosine column is this middle column, and it's going to be in between these two values here. Okay, so 36 instead of 37 degrees. Sorry, so 36 degrees. 36 degrees is slightly larger, so we're going to say 0.8090 and subtract the number we have, which is 8000. This one's an easy one to subtract, so we're going to say 009. So that's the difference. It's 9 thousandths away from 36 degrees. So now the next one, so it's going to be 7. Okay, so 37 degrees is over here, and that value is going to be 0.7986, and we're going to subtract that from 0.8000. Okay, and let's see what that is. So 7, that's 9, that's 9, that's 10, so 4, 1. So it's 14 10,000ths away. So this is significantly closer than that. This is a much smaller value than that. So 37 degrees would be our solution here. Okay. All right, almost done. Let's try 27. So theta's here is our opposite, and this is our adjacent. So opposite and adjacent to be a tangent function. As you remember, tangent, opposite over adjacent. So tangent of theta rather is going to be opposite over adjacent. Tangent of theta in this case would be 87 over 48. We're going to divide that off screen so we get 87 divided by 48, and that's going to be tangent of theta equals 1.8125. Okay, let's look in our tangent column. 1.8125. So tangent is this last column, 8125. So it's going to be in between these two values, which is 61 degrees and 62 degrees. Okay. So 61 degrees is going to be slightly smaller than that. So we're going to say, okay, so 1.8125 minus 1. Where is it? Let's see what we get. So 1.8125. I'm just subtracting this off screen, guys. 1.8040. So 85 10,000ths. It's a pretty small value for 61 degrees. All right, 62 degrees. Yeah, that's right. Yeah, okay. I thought I messed it up, but I didn't. Okay, cool. 62 degrees is going to be a much larger number, so we're going to subtract from that. We're going to say 18807 and subtract that from the value we have from it. So 1.8125. And we're going to subtract that off screen because I want to save time. There's 7 minus 1.8125. Okay. Oh yeah, this is like significantly close, further away. So 0.0682. So you can tell this number is much smaller, therefore it's closer to 61 degrees. So the hard part with these isn't really the trigonometry, it's just finding out the difference. It's really just the subtraction, honestly. It's probably going to be what gives people the most trouble, to be honest, because we just haven't done stuff like this in probably so long. Alright, so theta's here. This is our adjacent, this is our hypotenuse. And remember, adjacent over hypotenuse is going to be our cosine function. So cosine of theta is going to be adjacent over hypotenuse. And let's plug these in. So adjacent over 45 over 59. And 45 over 59 is going to be, okay, it's going to be this. Cosine of theta is going to be 0.7627 as a 1 there, so we keep it like that. So that's our value. We're going to look in our cosine column, which is our middle column. So 7627. So 7627. 7627. So it's slightly smaller than this, but it's bigger than that. Okay, so it's 41 and 40. Okay. So, all right. So 40 degrees, and it's going to be, let's say 6. Okay, so yeah, 7660. That's the value we have for 40 degrees, and we subtract this from it. 7627. What is that, 33? Yeah, it's 33. So it's pretty close. 33 10,000ths is pretty small. And 41 degrees is going to be, let's say 41 is, subtract from it, yeah. So 7627 is our number we have here. And the 41 degree value is going to be like 7547. I'm going to do that on our screen because, again, I'm being a little lazy here. 7627 minus 0.7547. Look how close that is, guys. Wow, that doesn't sound right. Oh, it's not. No, okay. I almost made a mistake there because it didn't look right to me. It's not close at all, but I thought that was the fourth place value. All right, so yeah, it's going to be 40 degrees because that number is significantly smaller than that. So 40 degrees. So I think you guys would probably agree with me in that of the 3 sets of problems, the final set is the most involved, and there's the most opportunities to make the most mistakes. So you have to be very careful when you're solving for the angle. It's just a matter of finding the numbers it's in between and then finding which number it's closer to. And a calculator will save you a lot of trouble. You still want to write it out to show your numbers, and then it's just better off after you write it down, then use the calculator. It'll just save you a lot of trouble. But make sure you write down the values just because you can follow your work. And that's all the odds. So hopefully that alleviates some concerns. I'm sorry the video went as long as it did, but I want to make sure we covered all of them. All right, thanks guys. See you soon.